this episode of FUM0074 machining, we are dealing with the tailstock of my lathe. It has been causing a lot of trouble because it doesn't repeat. Every time I move it, it moves somewhere sideways. If it would move only 1/100th of a millimeter, it would be no trouble at all. If it moved like 5/100th of a millimeter, I still could probably deal with that one, but now it's moving more. And it's every time I loosen it and move it somewhere, I need to adjust it. No, so therefore I have now started to deal with it. I already took it apart. So let's go on with that one. I'll show you what I intend to do with this one. Now I know when I took it apart. Well, here are the different bits and pieces of the tailstock. This is the quill, and there is an acme thread here inside. Well, it's okay. And a Morse 2 taper here. Here. So, absolutely, I can live with that one. It's okay. Then we have, these are the fasteners, how it is. This is to tighten it into the lathe bed. Handle, okay. And then we have this plastic piece. Well, it goes behind this wheel like that. And yeah, this is a bearing surface with plastic. Well, that's one thing I probably need to do something with. This is the key, and this key rides in this slot here, like that. And then from the top this comes down, and this is the brake. And please notice how this is the handle, how big the handle is, and how tiny screw we have here. This is not a good idea. It should be at least, I think, at least bigger. Okay, but I can still deal with that one, no problem. But then, okay, this is the piece which has this groove which goes to the lathe bed. So this is facing the lathe bed. Then we have the tailstock itself. This is one bulky piece of cast iron. And now there was a key, and the key is this one. And it was sitting on this slot. There is some slop in it. It's not tight. And then and then this was attached with this screw and a pin to the tailstock itself. There is the screw place, and there goes the pin. So it goes like this way. Goes, hopefully you can see. So it goes like this way here. Okay, and this is tight, so no problem there. Okay. But problems start to emerge when you adjust this. So it sits there, okay, and then these are the original adjusting screws. They are M8, and then some fancy thing here. They are indented to come from here inside like that. From the other side as well. And now this is really, they are wobbly, and when you have this piece here, the intention was that you screw them and then thus adjust the tailstock on top of this. Okay. First finish this one. There you go. Wow. Okay, attaching this piece of material into my vise. This looks hilarious on this machine, but at the moment this is the best I have. And well, yeah. So, and lucky me, this surface is by no means a critical surface, so I can just put it about there. Feel that it is about correct. Let's mill it. There you are. Not a big thing. Quite good accuracy by a hacksaw. But let's measure it with... well, always when measuring, you choose the correct accuracy instrument for your measuring. So, this time it should be 125 millimeters. And now we have... oh, I need my magnifying glasses. We have a lot more. This is oversized. So, this is 128 millimeters. So we need to come 2 millimeters away. I know that I can take 0.5 millimeter cuts with this one. So, let's do that. Let's take 2 millimeters off from it. So I left the last tenth for the finishing cut. Well, this doesn't need that, but just to practice. And now the last 5/100ths of a millimeter glide milling, and hopefully this machine can handle that. is the size now. Well, the finish is good, and our size, can you see this? Yes, you can. I level them there. Oh man, I have made some miscalculation. It's 126 millimeters, quite exactly. So I took only 1 millimeter from there. Okay. I let it be 1 millimeter too long, because it really doesn't matter. Well, this bothers me anyway, so I need to do this. Oh yeah, there you are. Now, bozo check is really always a good thing. This one tells me that it is 125 millimeters now. Okay. Then let's do some cleanup. Here we go. This is a 10 millimeter carbide end mill, and the reason why I'm doing this with end mill is that the center of the hole will be lower, and this time I'm using automatic feed. Yeah. Yes, one 10 millimeter hole, hopefully in the correct place. Well, now we have a 10 millimeter through hole, hopefully. Oh yeah. So here is what we are now at the moment with this tailstock. So, well, there is at the moment a piece like this. This is a key that goes in here, and as you could see, it goes there like it drops in. This should be tight. There should be no slop in it, and this has at least 0.3 millimeters of play. Damn. And then this surface is pretty straight. Yeah, okay. And then we have this thing sitting on top of that. That's the general construction, and now you are assumed to move this thing like this when you adjust the tailstock. Okay. Now, what I have done here, well, originally we had these two pieces. Oh, this is on autofocus. Let me see. Now it's okay. So we had these two pieces, which are, well, a joke, really. These are used to measure, to display where the tailstock is. So, bin. There you go. And what I have instead, well, the only interesting position is to measure that this is in the center, and or put it somewhere nearby. But after that you use your dial indicator, etc. But I did something like this. First of all, to cover these holes, which are obviously quite randomly put there, so I made a thing like this. Bought some new holes which are not randomly there, and I won't tighten them, but you have to believe me, this is pretty straight, everything. And then we have this screw, which is actually a through hole screw from the other side. There is a thread where, and then I have tightened it. It's like a stud, and then you put this here. So now when you adjust this, you can adjust that much, and then when you are have done your adjusting, then you just lock it. It stays in place, doesn't go anywhere. Well, that's one, and I believe this would have said be all I needed to do for this one, but I wanted to do a little bit more. So this was one thing. Another thing I have done here now is a key. It's not ready yet, and this is the key. It's you probably saw it in some earlier part of this video, but there is absolutely no play in it, none at all. It's a little bit tight when you put it there, and yeah, good. Okay, it needs at least one hole into it, and it's tool steel. Okay, then what else should I do before I oh yeah, of course there has to be a moving mechanism, and therefore I have bored these holes a little bit larger. There will be bushings, and then first of all in this side, in the front side a little bit longer, so you can set an adjusting wheel, and on this side just a bushing, because there shouldn't be a lot of play. There can be play in this case, backslash, because you adjust it and then you adjust it to another direction, etc. Well, yeah, but I want it to be quite tight anyway. And furthermore, these are the original adjusting screws, 1.5 millimeter. This is M8 thread. You took your screwdriver and then you screwing on the other side, tightened it. Never was good. And as you can see, it's only about this much thread you have there. It was wiggling like crazy. So then we have another thing here which is a little bit disturbing for me. This is the tailstock, this, and it goes inside here. Okay, as you can see, it goes all through. Okay, but this is all okay. There is some play in it, but before you center it, you lock it, and it probably locks on the same place, so you can repeat with that one. Then you have this thing, which is a bearing for this thing, and there is a thrust bearing surface which is 2 millimeters wide. Okay, and then this one has a dent here, a hole, and then well, it goes in like this. And then there was this set screw, which is really like it has a point. It's not and then you lock this into place with that one. Well, obviously that screw cannot take the forces coming from this side. When you push into it, it pushes the whole thing through. So, well, to take these forces, this thing had this hilarious thing. This is plastic. Screws with 4 screws here. Okay. And then it's there. And after that you had this type of a thing here, like that, and you had some play here. There is some play. And well, I don't like that play, really, I don't. It's too much for me, this one. And in this case, the bearing surface is this one, and then very, very small surface facing this bushing here. Okay. Well, I'm not very fond of this thing. I might leave it alone, maybe, maybe not. But what I will certainly do is to mill this like a key here, a groove. Not like this, and then this pointy thing, I will replace that one with an ordinary set screw which goes into that groove and then keeps it from rotating. So well, I will now I was thinking to make this piece out of real metal, but since it didn't break up, so let it be. It's not the best possible choice, and it has a little bit play in it and etc. But at least that wasn't the cause of my trouble. It was this sloppy thing here under. And this is now probably corrected, and I need the tailstock for a while because I need to do the adjusting mechanism here, and I need lathe for that one, and I need the tailstock for that one. So I need to put it together temporarily.